Hi everyone, my name is Anna Hughes and I'm a first-year graduate student at Oregon State University where I study ocean chemistry. Here we are today at the project warehouse known as RDesk, where we are receiving, calibrating, and testing equipment for the RCRV project. RCRV stands for Regional Class Research Vessel Project, which is the project that I am currently working on. In your activities, you have been learning about flux in different systems. Flux is a term that scientists use to describe the amount of something that is passing through a surface or unit area over a defined period of time. Flux can be used to describe many different quantities in a system, such as molecules like carbon dioxide, heat or energy, volume, and mass. I research ocean chemistry, focusing on the flux of carbon dioxide between the atmosphere and the ocean. This is a really important area of research because changes in the chemistry of the ocean are expected to impact marine ecosystems and other Earth systems. The amount of carbon dioxide in the atmosphere has been increasing over the past 50 years. This has led to an increase in the amount of carbon dioxide in the oceans. In the ocean, carbon dioxide reacts with seawater, which increases the amount of carbon dioxide in the oceans and changes ocean chemistry. This is a process that we call ocean acidification. Because the Earth is a system, we can study the flux of carbon dioxide between the oceans and the atmosphere to better understand how increases in carbon dioxide will affect ocean chemistry and impact marine ecosystems. Now I'm going to show you two of the sensors that I use to research carbon dioxide flux. This first system is known as the underway Apollo PCO2 system. It measures the amount of carbon dioxide that is in the sea surface by pumping in water from the sea surface through this tube and filtering it. The second sensor is the Picaro analyzer. This pumps in air from the atmosphere and tells us the concentration of carbon dioxide that is in the atmosphere. These sensors work together to tell us the amount and direction of carbon dioxide flux. For example, if the amount of carbon dioxide in the atmosphere is greater than that in seawater, we know that CO2 is fluxing from the atmosphere into the ocean. In reverse, if the amount of carbon dioxide in the ocean is higher than the amount of carbon dioxide in the atmosphere, we know that carbon dioxide is moving from the ocean into the atmosphere. In this example, the flux is being caused by a process known as diffusion. These are just two of the over 200 sensors that will be on the RCRV. As you can see, flux is a very important concept for scientists who study systems, particularly Earth and ocean systems. The RCRV will have over 200 sensors, providing large amounts of data and empowering scientists to study all different kinds of flux. Monitoring flux in Earth systems is very important for tracking changes in the world around us, specifically like those related to ocean acidification and climate change. In my work with RCRV, I hope that these research tools will help you and other scientists to think about the different types of flux in the systems around you, in your house, at school, or in nature. Ask yourself, what is important in this system? How can we measure the flux of it in this system? And what could be the possible positive or negative impacts if we altered that system? Keep up with the RCRV project by following us on social media.